Oh, geez. It's so hard to tell. I can't tell sometimes when the stream starts because it's not when I press the start button. So I just have to awkwardly like just wait there and wait for like the stream to like start doing anything. And then it's like, oh, okay. So that's game engine devs. We'll come back to that in a second. I just wanted a for sure reminder about how entities are stored because we're going to do it differently than the way I was originally like, I'm not going to say taught, but they're originally like self-taught. So that's going to be an adventure. But for now, let me just shrink this, move this over here, grab YouTube, grab my phone so I can see chat. Hope everyone's doing well today. Don't you guys like it when I breathe right into the mic? Oh, baby, that's hot. I don't care who you are, that's hot. Give me just half a second more. We are starting super late today, by the way. Super late. I did shave since yesterday. Absolutely I did. Heck yeah. Hold on. Mute me. Lower quality me. And then what am I doing? I am turning on music. Music is going to be... what are we listening to? We did Lo-Fi Leah yesterday, right? Let's do, I want to do Star Guardian. Vi. We'll do Vi sessions. That's a vibe, right? There we go. Okay. Not loud, but it's serviceable. Okay. Oh, I never pressed enter. Shit. God damn it. Every time. Oh, man. Discord. I'm so sorry. Oh, baby. Every time I make that mistake. Oh, it's so cringe. I'm like, wait a second. Where is everyone? I was like, oh, I never actually sent the message out. Whoops. That was a mistake. I was like, hi, guys. How's it going? Sorry. I'm all sweaty. It's so hot today. Oh, it's so hot. I thought I was going to die. It's like 95 degrees. It is blisteringly hot. So let's get into it. Let's do everything. So that goes... Wow, really? Zoom in, please. Thank you. Zoom out, please. I mean, that's one way to do it. There we go. And then do this. I mean, okay. There, that's... Oh my god, what do you want? Okay, hold on. Okay, this is too big. Stop. Just go right. Oh my god. There we go. Okay, that's kind of it. We're kind of there. We're a little bit there. Okay, and then to the right will be Visual Studio, so Wafture. And this goes over here. Fuck, no, just right here. Okay. This goes, oh, I guess I could make this bigger, huh? Quite a bit bigger, actually. Well, maybe not. That's not bad. I don't hate this. Okay. I think we're just gonna settle on this. There we go. This is a nice balanced situation, right? This is all good, right? Okay, I think this is a vibe. Let me just take a drink of water and we'll get started proper here on actual entity implementation. So I think what we're gonna do is, so we have our like basic structs, right? We have our super basic, maybe we make like, I don't want to make this an enumerator thing here for damage types because maybe we want like combination or something. I think we'll just do fire and cold right now though. So what's this all about? Well, what we're gonna do is we are going to make an entity that has these structs in the engine, right? So let's do that. We are going to export entity, and we're just gonna call it entity. Oh, class, sorry. Class entity. Cool, right? So classes already list private as its first thing. I'm gonna do that anyway because I just think it looks better. So what are we gonna list as a private entity? Okay, bear with me. So every entity is going to have a list of components, whatever that's going to look like, right? Now, what we're not going to do, I think, is because we want to go pure ECS, we're not going to have like bullet entity, hero entity, whatever entity. I think what we're going to do instead is we're going to have a tag system. This tag system will do all of the sorting for us in terms of like, you know, like if we had like, you know how in like Toho games, there's like the bomb button, which clears all the bullets off the screen. Well, what makes something a bullet? Well, it would have the tag bullet. So that's kind of what we're going to be doing here. So we're going to have a tag system, but we'll get to that in a second. So what we're going to do, oh, I am now connected to chat. Sorry if I missed anything. I don't know why I wasn't connected before, but there you go. So what we're going to do is we're going to have, well, what we could do, and we're not going to, is have like a bunch of like unique pointers. Unique pointer is moving, movable, something like that. We're not doing this. This is a nightmare. Oh my God, please. Also, am I spelling this wrong? Unique. Oh, sorry. That's not what we're gonna do. What we're gonna do instead is a little bit different. We're gonna have a standard tuple. Now, does everybody here know what a tuple is? Because the answer is you don't, and you're a liar if you do, okay? A tuple is an array. What? It's just an array? Yes, a tuple is just an array. That's all a tuple is. A tuple and an array, the only difference between them is that an array enforces type value and a tuple does not. So you can have arbitrary types in the tuple, but they have access, you access memory right there, right? It's the same as an array. It has the memory benefits of an array, but it doesn't have to be the same type. So we're going to have a tuple of all of the type names, I think, of every single component an entity could possibly have. And then what we're going to do is, because they contain these values, we will then have some sort of public thing where it's like void, or here we go, auto void add component, and then argument type T with parentheses, you know, arguments. Like that kind of deal, right? That's what we're going to end up doing. And then like, oops, not auto void, excuse me. Void, what's a better word than subtract? Or yeah, is there a better word than subtract for like the opposite of adding a component? Remove component? Rem component? I think that's a better one, right? And then we're going to remove components this way as well. So we have a T here, because this T is going to be part of this tuple. That's how we're going to implement this entity system. So let's use an example here. Whoops. There's one I want to see here. Now this is Game Engine Devs, the subreddit. I want to see how they implement this, if it's the same. So what they do is they have some structs like we do. Then they have a const express size, max number of entities, yada, yada, yada. Then what we're going to do, then he has a bunch of arrays and a namespace for data. Struct position. No. I'm surprised he doesn't have the name entity. So what's like the substitute here? Damageable, drawable, velocity, position, namespace data, tags, positions, drawables, damageables. Ah, so this namespace data is how he implements his entities, huh? So what he does is he has an array of tags, an array of positions, an array of drawables, an array of damageables. He doesn't even have an entity. Wait, this is an example of ECS though. And then he has some flags. That's his system for updating kinematics. That's his system for drawing. And in his main loop while running, update movement, run another systems, update draw. That is basically the naivest possible ECS implementation. It should give you a rough idea. The only thing I can imagine needing to use inheritance for is if your component storage container requires truly unique types. No, we're not going to need that. Otherwise, the use of inheritance in the core of an ECS architecture would be a major code smell. You should be aiming for the absolute flattest, least hierarchical, most contiguous memory layout you can achieve. I thought the point of ECS was to not store data for entities that don't use it, i.e. maintain a dense organization of all components. Your simple ECS still stores data for every entity, regardless of whether or not that data component is used. Here's a simple example that relies on the mapping entity IDs to component indexes. The point of ECS, oh, we got disagreement. The point of ECS is to completely decouple state and logic and generate all composite behaviors from composition rather than inheritance. The natural side effect of this approach is that it lends itself strongly to data-oriented design for high performance. The actual implementation of the storage has nothing to do with the ECS architecture, concept itself. Quite aware this is highly limited. Also the fact that I wrote it all in a Reddit comment. ECS architecture should be very flat and optimize memory contiguity, not rely on polymorphism. Paging, okay. Your average component is 64 bytes, high guess, and you use all 64 bits, and you want to store up to 256 active entities. It only adds up to about 1 megabyte, which is a trivial amount of memory to use. Not saying there's not room to improve. Interesting. I don't really, it's like the non-factory approach to like doing entities. It's very weird. You can either have the component storage outside the ECS manager, e.g. a static function get component data, or use RTTI with map inside of your manager, but whatever the solution, you should make the API unaware of the implementation. Yeah. Code Toil, welcome. Welcome to the reading how people do ECS online kind of deal. Okay, so what we're gonna do is in our entity, I'm probably gonna call this the entity. No. This is an entity, and then we're gonna have a separate class for managing the entities. So add component, remove component would go in there, right? So it'd be export class entity manager. And in this entity manager, this would contain the add remove components, right? I've been ignored for one stream. I feel like I've been forgotten. Sleepy Mushroom, you didn't ignore. I saw your comments. I know what you typing. I see you lurking there. So I'm trying to think about what I want entities to have. I think they should have a tuple of every. Do I want them to have a tuple of every component? So if later on somewhere else in the program I was like, we'll have like entity E, right? So like if E dot is shooting then do this. The problem is, no, we won't even do that. We would just do this. So the problem is if I have a tuple with this struct in it, so it would be standard, probably a unique pointer, or it might be a shared pointer, I don't know. Standard unique pointer is shooting. A tuple needs at least. Class qualified name is required. Oh. Wait, what? Oh. I need a name for that. So if I have this existing in the program and I say, is this shooting? assuming this is true, that would ring true, right? I think it would. I'm writing one of my games in JavaScript. Well, TypeScript, it's a subset of JavaScript. I have to learn Java and JavaScript, but not yet. First is Python for just intro to programming. And then after that, we have object-oriented programming through Java. I have that for 2 terms. And then I have JavaScript. I know I have SQL in there too. Why not vector, unique pointer, random variable, and then random variable pushback, random pointer? So the reason why is because the biggest downside of vectors is that you have to have type, matching type, right? A vector can only have type, you know, unique pointer is shooting, or unique pointer damage type fire. Well, these are all bools, but like unique pointer health, you know, unique pointer hurt box, which is an SDL floating rect. I want it all on just one container. The alternative way, I guess, is to have a container for health, a container for position, well, a 2D array, but we won't talk about that yet. A container for all the damage values, a container for damage type waters, and just have arrays for every, or vectors for every single individual component, and then adding or subtracting components to things adds them to those vectors. That's a way to do it, right? Well, yeah, is it not based off all that? A superset? Yeah, I don't think we're doing a vector here. I think we are doing a tuple. Vectors enforce type similarities, whereas this is going to look something like, oh my god, I don't even know how to phrase this. Comma, and then it would be standard unique pointer is moving, comma, standard unique, it's so hard to type when it's zoomed in, unique pointer health. So all this is doing, this giant tuple here, all this tuple is doing is just giving an array of unique pointers of different values, right? Does the existence of this tuple in every entity mean, how do I add a component though? This is the wrong way to do it, right? What if a tuple is variable length, right? Could I add something to a tuple after I do something with it? So e tuple dot. No, I can't, right? Yeah, because if it was a if it was like a standard vector e. Oh. Int. Then e2 dot. Oh, wait, what? Am I dumb? What am I forgetting here? How do I not e2 push back? Declaration has no storage. Oh. Wait, it's a vector. What? Am I dumb? What am I missing here? Why is it not giving me access to like all the vector functions? Have you used standard pair? Yeah, it's just a tuple, but it forces you to only have 2 values. These are, in a pair, you can have like arbitrary anything. You could have an integer and a float. It doesn't enforce type similarity, unlike like an array. That's the only difference. The only difference between an array and and a tuple is just, you know, type forcing. Tuple is just an extension of that, so more elements in each. Yeah, exactly, sassy fajita. You're not in a member function? Oh. Oh, I see what you're... No, I don't see what you're saying. Void example... standard... vector float... example v... example v dot. Okay, so there's my pushback stuff. Okay. So now instead of a vector, if I had a tuple and I did example v dot, there we go. That's what I wanted to. So like three-way comparing equals swap. We're never going to do any of those, right? Literally, it is just a container. We're not actually doing anything with it. Okay, sweet. But in any case, if I have a tuple containing all of these values, I'm a little worried that what we're gonna end up doing is just having like object inheritance, where we're gonna have this object entity that has every component by default, and then we turn them on and off? What I'm worried about, because these don't have initialized values, right? If I give every entity, every component as a part of the tuple, so it would be like, you know, whatever, 100 components long, for example, just because it exists in the tuple does not necessarily mean it's a component that we added, right? To the entity. It's just, it exists as a tuple. And I'm stressing about this, or not stressing, but I'm thinking about this because if every component is in the tuple, then does every entity have every component all of the time until we turn it on? In other words, I thought we were going to be like adding to a vector or something to give it the value of that component, to give it the pointer, right? You initialize it on the constructor. Because that's the declaration. Use vector float e2 1 2 3 4 5 6. You initialize it on the constructor. You're trying to put code directly in the class declaration? But no, that's not what we're doing, right? The whole point of ECS is to completely separate the state of a thing and the logic of a thing. And what's difficult about that is, unlike regular object-oriented programming, which you would be like, okay, this is my entity. We're going to construct it with, you know, we want like a int ID. We want like a bunch of other stuff. And then you're going to be like, okay, this is how you define it. And then you'd have like some body if you want it, right? That's how you would define it. And then you would like do all your member functions and everything. But here, unless we're doing like the entity manager, but we'll talk about that in a bit. The entity itself is not going to have any methods or anything, right? So when I think of like initializing this entity, like maybe we'll have like a static. Oh no, it wouldn't be static, would be. It would be like int ID. I don't know, just int ID. Maybe MID. So it'd be like entity m, or it'd be int ID colon m ID ID body semicolon. Did I initialize this right? Is not a non-static data member or base class of class entity. There's a syntax here I'm missing. Is it curly braces here? Nope. There's something I'm missing. There's some syntax I'm missing here. Oh, I'm spelling it wrong. That's why. It was a syntax issue. There you go. So that's how you would construct the entity. And I think that's all we need for the actual constructor of an entity, right? All we need is a unique ID. Well, all we need is an ID. Now, obviously we have to do things to make sure no two objects can have the same ID, but maybe we do make it static where every new entity automatically assigns it a new ID. I guess. I don't see why that can't be static. No, it can't be static, right? Because if it was static, then every entity in the entire game would have the same ID number, because that's what static variables are, right? Static variables have the same value across all instances of a class. So this cannot be like static ID. That would be horrible. What I could do, instead of just maybe manually assigning it ID, I guess I could, when I make an entity, give it an ID number. And when I do increase the ID number, this sounds like dumb, but understand that I think, oh, we also need like a vector for tags. I kind of like the idea of that Redditor who was like, okay, somewhere in your program, you're gonna have a namespace data or something. And in namespace data, you're gonna have like a standard array of type, I don't know what kind of type, int. And, no, wait, this is tags, right? What? I guess it'd be a string? I guess it would be a string then, huh? Standard string. And then it would be of size t, whatever the max size is. It doesn't matter. Just give me a big array. And then, why doesn't this work? Type name not allowed. What the fuck? 5,000? Jesus. And then we'll call this like tags, you know? We could do that. Just some big like block of memory we block out for like individual tags. And then later on, we can reference like data namespace tags or something like that. That would be a way to do it. The problem is I don't know how well that plays into our factory that we're gonna need for entities. Like, well, how about this? If we have a factory of entities, is that going in the entity manager? And if it does go in the entity manager, then in order to make an entity, like how do I want this even to be called when I make an entity, right? So if I want to make an entity, what do I want to type? I want like blah, blah, blah. So whatever that looks like. Then I want the make entity. And when I make an entity, I want a name string. And then to define like tags. Ooh, I don't know if I want tags here. Because I can give tags, right? So I maybe just want a name, maybe an ID number here. Probably not the ID number. I probably just want a name. So it would just exist. It doesn't even need a name. It's just make entity, I don't know, bullet. And that's it, right? So just by it existing, and then I would be like bullet dot give tags bullet info or whatever, bullet tag or whatever the tag looks like for bullet. Maybe we do like shotgun bullet dot give tags bullet, something like that. Maybe that's what I want it to look like. I'm just trying to think about like how I want to actually like see it, you know? I'd put a generate UID function in the entity class, and the function itself would have the static data needed to ensure that it returns a unique value. Would that go under the entity or the entity manager? I feel like that's like an entity manager thing. When I hear of an entity as an individual object, I don't think it should concern itself at all with like the actual like what value of ID it gives it. I feel like this implementation is maybe even fine so long as when we call an entity or when we make one, we call the entity manager. So maybe the add component, remove component goes under the entity stuff. Holy shit, I thought I was so well read on this, and this is so complicated because the problem I'm having is like there's so many issues here with how we're doing things so far. Because if I'm trying to think about how do I phrase this. If I make an entity, and am I doing it through the managed entity manager? Or am I just calling the entity class, and by the very existence of this entity, the entity manager then does everything? Oh, alternatively, I guess we could just have the entity manager take care of like any logic with entities. And then we have the entity itself actually containing your ID, actually containing the tuple. The entity manager doesn't actually have any information on there for the entity, just the logic to manipulate it, like adding a component, removing a component, that kind of thing, yeah? So that's what I'm thinking. But what's the benefit of that over just regular object-oriented programming where you would have an entity, class type, whatever? Because that would contain the methods to change everything. I guess you have nothing to do with systems, right? Systems is its whole separate thing. We're not even to like how you change the individual values of a matrix yet, right? This is just how to add and remove components from an entity or how to construct one with them. So that would be a thing, right? I guess I do need to do more research. Damn, I thought I was ready for today. I apologize. I just have to. Hold on, Reddit, ECS implementation. What's your way to create an ECS? Game dev. What ECS does in my mind, you need some entity IDs. Unity uses 2 ints, one for version and one for index. We're not gonna have an index of IDs, okay? We're gonna have one raw ass integer and that's it. Using the version to stage during loading buffer and entity creation, destroy and recycle mostly. We define arrays of components, and if we don't write the whole engine, rather a game, we may end up with just a bunch. Okay. I mean, we are making an engine, right? And then the game just gets made with that engine. And if there's any features we need to add, we just add it to the engine. We're like our own back-end programmer as a designer, right? That's how you do your own thing. My opinion, from what I know from the games I've made, with object-oriented programming, the games I've made, is you make the engine as it is, and then you go and make the game, and it's like, oh, I need this feature. You go back to the engine, you add it, you test it, do all that stuff, and then you go back to designing and you make the game, right? Usually it's like a bouncing back and forth kind of deal, and you just add features as you get them. That's why I'm excited to try out this whole ECS thing that's gotten a lot of hype in the video game industry, because then I'm able to do a lot less, hey, I need to add this to the engine to make it to work, and more of the designing, the fun part of the game design. The design is the fun part of making games. Everybody wants to do the design, right? So the idea is I would be spending more time designing because everything is component based, and if I need something, I can just combine components or just add it as another component here and then just give the system logic. Like, it's a lot easier to be more iterative with it. So I just want to make sure I get this right, the actual entity part of it, because once I get the entity part of it ready, like multi-threading, all that stuff is going to come way easier. It's just the initial foundation I want to make sure I get correct. So we define the query mechanism to get one or more components in the most efficient way, querying them based on by component types and optionally entity index, where the latter is getting closer to random memory access. We're probably going to have a map, right? I don't see any reason for components of any individual entity to be in order. We're not swapping them. We're not organizing them. We're not changing them. All we're doing is just having systems that iterate through them. Oh, No. It's going to iterate. That's not what I'm saying. Systems will iterate through all entities that have like is movable. We're not going to have every system like iterate through every entity on the screen, right? That would be silly. That means that every system would be like the gravity system would be iterating through the UI. That's very incorrect, right? So maybe what we would do instead is if you have components X, Y, Z or whatever, then you get added to a vector and then the system. No. If you have a component like is moving, then you would get added to a vector and then a system would iterate through that vector. And if you have another component to compare against, like if you're moving and affected by gravity, then you would get affected by the system physics. That's how you would do it. And in that sense, is it bad? That would be a vector because you're iterating through things sequentially, right? And you want that to be an array or a vector or something with like sequential values. But on the other hand, if you are doing something like adding components to a, where is it? Adding components to an entity, do we need a tuple? I was thinking tuple because it's an array that doesn't have the same type casting stuff. But maybe a map is better because then a map, you could access components without necessarily worried about iteration. I don't know. I'd have to think about it. And that's kind of important, right? Like it's not super important. You're not like iterating through every component of an individual system. You're just checking if that shared pointer value or unique pointer value in our case exists, right? Like the existence of that unique pointer in the entity. Is it there? Okay, we're good. But moving on, right? It's not actually using the values when you iterate. So I think that's fine. Systems may be any bunch of code that queries and runs tasks and jobs. Okay. Confused about ECS implementation. How big, small should a component be? Very small. Maybe we can answer it. Is it normal to have so many copy and paste chunks? No. I mean, for an example, in my implementation, I parse the scene from a simple text file. So if I know if I have to add a component to an entity, what I do is generally check if I have reached the maximum number of components for this type. No, this is a bad implementation, right? If you're worried about, if you need to add a component to an entity, I think what you would do is you would just give the entity the component, right? You would do like a simple error check and be like, if entity does not have component, then add component. If you know they need it for this specific function and you know they have to have it, that's something you would do like as an if check or something. How big, small should a component be? Very small. Very, very small. Like each of these are only one value. It's a point. A point is 2 float point values, but you get my point. Render rectangle, hitbox, color, HP, damage value, yada yada. Do I want the render rect to be an SDLF rect? Because you can't rotate those. You can't rotate those. Rendered rectangles are always X and Y aligned. Are we ever gonna need to rotate anything? We will. We will. Yeah, we will. We'll keep that there for now. What's up? How's it going? We're looking up, well, I'm trying to make sure I get this entity thing right before we continue. Because I want to make sure that this tuple, which is how we're going to store all of the unique pointers for, well, how we're going to store like every single component an entity could have. It feels wrong to have a tuple in every entity that contains every component at all. That feels weird. That feels like I'm giving every component to every entity. Maybe grab the code from the shooter game? Nope. Whoa, for the rotating rectangles? Oh, definitely no. No, because we screwed up our math and it's a little bit goofy. It would need a refactor. The actual implementation is fine. Like in terms of, in terms of like calling the functions, it works as intended. It's perfect. It needs a refactor though, because the math is actually incorrect and we corrected it incorrectly and it needs a refactor. But I don't want to do that. I'd rather just start from scratch. Okay. How should a system work? We know. Excuse me. Am I overthinking this? I must be overthinking this. I have to be. Maybe we'll just continue and we'll go from there, you know? But it feels really inefficient to be like unique pointer, position, unique pointer, bounding rect. Like, I feel like I can't be doing this for every entity, right? This is such like such like you're repeating yourself kind of situation. Are we really doing this for every entity in the entire fucking game? No way, right? Or no component, no way, right? This feels super unnecessary. So it'd be like, it would be hurt box. And then it would be color hurt box. And then it would be health and damage value. Like there's no way I'm gonna be having like 100 unique pointers in every tuple. I don't think entities store components. Oh my God, what's up? You're a goddamn genius. It would go into the entity manager, son of a bitch. Ah, yes, you're right. What's up? It would go in the entity manager because now we could do something like, whatever this would look like, add component, whatever T would be. So whatever one of these, in the tuple, and then it would be like arguments. No, it would be the entity, right? Entity E. That's what it would look like, right? We would just have to make what the add component template would look like. So the idea is that we would have an entity manager as an object. This object would contain a unique pointer, well, a tuple containing unique pointers in every single element of that tuple. And whenever we want to add one of these unique pointers, the component, to an entity, we call add component. So it would look like add component. Oh no, it'd be like e manager dot add component type whatever this, I don't know if we would reference this by here or by value, that parentheses, and then we would have our entity. So it'd be like player. So it would look something like that, right? That must be how this works, or how we should make it work. It's either unique pointer position or like 0, whatever the value would be of this. Oh, wouldn't it also be e manager dot e tuple bracket 0? That would be a way of doing that, right? Although 0 I hate. I don't like the magic number. From what I learned about ECS, each component type usually stores separately, like array position positions, array hurt boxes. So that is a more efficient way to make a video game, because that way the CPU doesn't have to bounce. Sorry, I'm leaning back in my chair. The CPU doesn't have to bounce to different places in memory in order to get something done. That's like the weakness of object-oriented programming, right? And ECS allows you to easily organize your data because it's data-driven programming, right? If that's the case, we would still use the tuple. And instead of a unique pointer position, it would be standard vector, standard unique pointer position. It would look something like that, right? And then that would be the logic throughout every single value in the entire, every component in the entire thing, right? So if that's the case, then you would add whatever vector it is there. This is what the ECS people want you to believe. Hey, ECS is based so far. It's just I've never actually implemented it myself before, so I don't know if we're on like, oh, that hurt. Oh man, I buzzed shades. I had an ingrown hair on my lip, and I just absolutely demolished it. Ow! Oh, the struggle. You know, Gary is an ECS person, right? I am an ECS person. So I still like the idea of the tuple because a vector wouldn't store this information, right? Yeah, it would have a huge problem. A tuple doesn't care what the object types are. They're arbitrary, but I do want one object that contains all of these vectors. So that's where we're going to store all of our entities, and then we're going to have our component get added here. I think, do we need a separate class for template stuff like this? Alternatively, I don't even have to do the T dumbass thing. I could just be like entity and standard vector. Oh God, standard vector, standard unique pointer. Oh, this is where it gets a little tricky. Because I don't know what object type it's gonna be. I guess I could do auto. Auto component, where these are one of the components. And then the implementation would be entity give, how do we actually add a component to this? That's why we originally had the tuple here anyway. Like, how do I actually define what this is capable of having? Look at Discord. What is the point? Global warming be like, I thought it was gonna be like some helpful information about like ECS and shit. Huh. Interesting. Oh God, that's the wrong picture. Sorry, we rendered a triangle in OpenGL. I was proud of it. Really? There we go. Triangle. Hell yeah, it's a triangle. Chad, do you like my viewership today is going from when we started like 6 viewers and then it went up to 18 viewers and then it went down to 10 viewers. You guys are very bipolar when it comes to how much you like to watch programming. So maybe this is the wrong implementation. What does actually, now that I think about it, what does that guy on the college course say about it? He did like an entity factory thing, right?
Being finished those parts of the project. Okay? A little of the game done. Project.
No, that's not it. Hold on. Hold on. Ugh. History. Who did that? Code Toil, thank you for the bit. Whoa, lots of bits. Oh, geez, 95 bits. Oh, man, thank you. I appreciate it. Okay, hold on. Let's look at Mr. University guy here. Let's see what they say. So yeah, this is ECS. It's beautiful and it's nice, and I'm definitely in the way.
Control.
Stop.
Right? It's controlled by an AI. So it would have a position so that it could be in the environment. It would have an AI so we could it would be controlled by the AI system.
Now try rendering a triangle in Vulkan. Nah, let's make a game and then we'll worry about 3D rendering. Okay, don't worry. I have a whole university course on it coming up. All right.
It would have a sprite to be drawn to the screen.
Okay, so we know all this. ECS programming. Example entity components, player, position, speed. Yeah. We know all this. ECS example system. Okay, yeah. So systems for ranged for loop, all entities, position plus equals entity speed. Yeah. So this is like super simple, right? Engine architecture, game engine, scene, systems, entity manager, entity component. Oh, so the components do go under entities. What the fuck? I thought it was like an entity manager thing. Oh, that's a good video. It is a very good video.
It's a different scene with different things.
So I knew
drawn,
this. So scenes are like main menu, game, options screen, that kind of thing. Every scene is different. It has a whole different system.
Different entities, different properties, etc. To drive this home, and
ECS components just data. We know that. What is an entity? Any object in the game. Yep. No unique functionality. Typically stores a number of components. Stores at most one of each component type. And that makes sense, right? You don't want like a player to have multiple position values. You want one position value and one value you can always balance against and move and all that, right? You don't want multiple hitboxes. You want a single array that has every single value of the hitbox in one instance in the whatever object you're wanting, right? It's just the relation, not how they store it. Okay. Components will keep a reference, the entity ID, so each component will belong to an entity. All right, we'll see.
One of position, how components are stored and used within an entity, you can write a PhD thesis on.
Fuck. Okay. Shit. This is where we're like, this is where I need to make sure we get it right. And of course, it's like the most complicated thing. All right, let's keep going. Component storage options. Okay, maybe we should listen to this. This is where we're floundering here.
That we have to answer. So, since there will be at most one of every component, store a variable for each component type. So this is the first and simplest possible way to store.
Since there will be at most one value of every component, store a variable. Oh, I see what it's saying. So rather than having some vector of positions, he's saying an option would be, okay, well, if you have an entity, what you can do is you can just give it, you know, Boolean shooting, Boolean is moving, or whatever the equivalent of these structs are, right? So it would be like, instead of is moving, it would just be, is moving there. So every entity would have like its own object type. So he's saying that's option number one, but we're not going to do that
within an entity. If I am going to, the first one is component. Okay. The second way of doing it is to store a container of components inside the entity.
Okay.
And then we could use functions to say add component or get component for a given type. Okay. So this way ends up being a little nicer because it allows us to put extra functionality and like data management on top of things.
So this is where we started, because originally this was under entities. So I had a private MID integer and a tuple containing all of the vectors for every object type, right? That's what we had. Well, originally it was a unique pointer, but we'll ignore that. So this arbitrary value of different components, that's what we originally had. So maybe that is the way to go.
Allows us to be, and we'll talk about this in the future, more cache friendly stuff like that. So this ends up being a little bit nicer. However, we are going to start with this one so that you can appreciate later on why this one is better.
Well, we're just going to do the second one.
So here is the easiest possible way that you could implement. Now, okay, there might be some other easier.
This is bad, right? This is like old school, like memory management, where it's like you have the pointer. These are pointers, by the way, not multiplication. So it's C transform pointer, C transform equals null pointer. C name pointer equal, or C name object type pointer name C name equals null pointer. So he's just giving the values to the entity directly, establishing these pointers as null pointer, and then later on freeing the memory when the object's deleted, right? Or whatever, cold from the screen, whatever it is, right? So this is bad because this is not utilizing RAII as we know it in C++. So no shared pointers, unique pointers, all that stuff.
For C++ classes already. So here's our class and those things. I would just say, hey, entity dot
Okay,
one.
we already know.
This is kind of an unsafe architecture because giving public access to raw pointers allows us to have dangling pointers and memory leaks and all sorts of stuff. So as we talked about before, what we're going to do for our first implementation of an entity in this course is instead of using raw pointers, we are going to be using shared pointers.
Okay, and we're not using shared pointers. We're going to go the extra mile and use unique pointers. It's going to be more verbose, but shared pointers have their own performance issues that we are going to be avoiding by using unique pointers. And that's all that the difference that'll make. Shared pointers are fine. So this is not how we're going to do it though, right? We're not going to have public shared pointers, name, shape, box. Yeah, this is not how we're going to do it, but I get the idea, right? This is just how you store components in an entity if you really like, if it was like a hobby thing, you know?
Okay. Now, I can hear the industry people already saying, shared pointers are so slow. Oh my God, don't teach them how to use shared pointers because they're going to get hooked on them and all this stuff.
Okay, well, they're learning. They're learning. It's fine.
Is to get them, they've been a collection of
okay, what's going on here?
Way of doing things. The other way of doing things, which we will talk about more later in the course for assignment 3, is a collection of components. So rather than having individual variables for each component, we could think about having some sort of collection of components. For example, a vector of component base classes that stores derived classes and all sorts of stuff. Then what we might be able to have is instead of having raw access to those pointers, right? This would be a private member variable. So we couldn't access the components directly, but we would have templated functions which allow us to add a component of a given type or get a component, or remove a component of a given type. So this would be like a hand-wavy abstract view of a collection-based architecture.
So this is what we're doing, right? So it is, okay, so it is an entity that contains a lot of these, and this would have my add component, like get rid of component, all that stuff, right? Interesting. Okay. So that would be how I add and take components. Interesting. Okay. That sets me off in the right direction. I still don't know how you're gonna add a component in terms of like actual use case, but we can figure it out. You can run, but you can't hide from object-oriented programming. This still isn't object-oriented programming, by the way. I mean, I guess these are methods. I don't know. He said, well, if they're templated, if these are templated things, so he was doing like object type T, and instead of an I guess you don't need entity anymore because this is the entity we're changing. What you would do is you would have like auto value whatever, right? So you'd have to make like, the reason why you would do that is because when you give a component to something, you need to give it some value, right? It's probably how you do that. I don't know why you would take an opponent with give it a value, but there you go. So I think that's how you would implement that. That's what it feels like, but it requires us to template out what T means, which in this case would be a unique pointer to some value. Well, actually, because they're all unique pointers, there'd probably just be any representation of a value. So probably just a template, right? Well, we'll cover it though.
Now, it turns out from my personal testing, I've done, I wouldn't say extensive, but like probably 20 or 30 hours of testing this architecture.
Okay.
And I think that instead of using a vector of components, in C++, it's actually much nicer to just use a tuple of components. And
first of all, it should be pronounced tuple. Second, I am a fucking god. Woo! By the way, thanks for sharing that resource. Not a C++ guy, but it was nice to see modern C++. Yeah. I mean, it's not super modern. I would consider modern C++ to have module interfaces. Modules, RAII, so like unique or shared pointers. The use of the word auto and then never templating anything for the rest of your life. If you see a template, it's not modern, but you should know what templates are. So yeah, that's modern C++. Everything is auto. Always auto, right? I'm a big fan of that. Always auto. And modules and RAII. That seems to be like the big modern C++. And give it like 2 more years and you'll have like reflection and all that. Oh, it's going to be easier than ever to make games in C++. It's going to be fucking great. All right. Cool. So now this is correct, where every component is going to be a vector that contains a unique pointer of a position. Can I just say how ugly this line is? Look at this. Standard tuple, standard vector, standard unique pointer, position. That is a lot of standard. Almost makes the argument for a local using namespace STD or something here. Using namespace standard in this specific space, but I think it's fine. We may end up doing something like using whatever to represent this or something, maybe. I don't know. We may have to have a using or a type def to represent this phrase specifically, where this is type T, where I can change it. That would be nice. Let's keep going with this. I don't know how much more we can learn from this guy, but I do like where he's going with it.
I'll get into why that is later in the course, but this is what we will be moving to for assignment 3.
Okay.
So for assignment 2,
no, not doing that.
Going to be for storing components within our entity. And it's really cool to actually use this for an assignment to then be able to appreciate why this is better in the future.
Oh, it's better, by the way. Tuples are better because you don't have... Because a tuple is just a fancy name for an array that doesn't care about... It just allows arbitrary object types. They don't have to be the same. It can be an integer, float, double. It can all just be in the same array. That's all it is. It's an array without static object comparison. I forget what it's called, but it doesn't enforce that. That's all a tuple is.
All right. So that is how we're going to implement our entities.
Okay.
Now, just keep in mind,
I'm now more interested in like the application of like, okay, how do you actually add a component to this? Because I see it, I can try to implement it. My worry is well, I guess, how about this? If this is class entity containing tuple, all the components, right? I'm assuming these components, by the way, are all vectors of every component. If that's the case, do I list every single component on the thing? Do I list them all? Is that what I'm doing here? Or am I listing some of them? That's where I'm a little bit confused. Although oh, you know what? I bet you don't. Because now that I think about it, if you add a component, I think what you might just do is push back on the tuple. Wouldn't you? I think what you would do is, in order to add a component, you would just add some component to this tuple value, like push back on the end, and then when systems iterate through to like, if you have this value, then all it would do is just be like, oh, it is in the tuple. Yes, you have this value. It's a pointer. Boom. You have the value, so the if statement proves true. Standard get t. I have never used standard get before. Interesting.
To be a little bit more data attached to an entity. It's not going to be just this.
Okay.
There's also going to be like a unique integer identifier attached to each entity. We'll talk about that in the future. But for the most part,
we already have that though. That's this. But we just have to change the implementation because I don't want a situation where you make an entity and it has like, you list the ID number yourself because that's screaming for error. I think what we're going to do is have this same exact implementation we have here, but in our entity manager, when we actually create entities, it's going to give it a unique ID number to construct this entity with, whatever it is. Also, these shouldn't be here anymore then, huh? Because if these are here, then they're not able to be added later. Okay. But I guess that's where tags come in, right?
This is how we're going to store
get position m component equals arguments. Oh,
our components, which is the majority of what we need to
It's good practice though. If nothing else, I'll learn how to I'll learn how to think in a way that's like data-driven programming, because this is my first like data-driven project. Everything else in all of my experience has been object-oriented programming. It's really hard. I don't know if it's just a me thing or if everybody goes through this. It's really hard to get my head out of the space of like methods and like class objects driving the programming. That's difficult for me to get my mind around. That's why we're like taking this super slow at the beginning. Because once we get this like base system down and we get to like programming systems logic, oh, I can do that all day. It's more so a, I want to make sure I get the entity storage stuff down.
About when implementing ECS. Mm-hmm. So again,
we know
components.
Okay. What's this?
Later. So how are we going to implement the components now that we have, we implemented the entity first. Okay. Now, how are we going to implement the components? So in this class, or in this course, I should say, because the word class is a bit overloaded. In this course, we will have a different component class for each component type that we want to implement. Okay, so I'm just using class.
In this class, we will have a different component class for each component. Okay, so he's overloading class. I see what he's saying now. So in this course, we will have a different component class for each component we want to implement. A different component class. Is he saying that these structs are what he defines as classes? Because I wouldn't define these as classes personally. I think these are just data structures. Unless he means every struct is going to have an associated class with it when it comes to like adding it to its own vector or something, then that's something I didn't see coming. I didn't think it would be the case. I'm assuming this is what he means though, where it's like every struct is its own class.
Classes to store those data. The naming convention we're going to have class, and it's going to start with a capital C for component, and instead of typing out component each time, it's going to have the component name here. So
is that a better way to do it? I guess it is. Okay, so C position, C bounding rect, C hurt box, C color hurt box, C health, shelf, C damage value, C damage type fire, C damage type water, C is controllable, C is damageable, C is shooting, C is moving. There we go. Sweet. These are going to get deleted. I can already tell right now this is going to get changed. Tuple containing no values. So the beautiful part about a tuple is that a tuple doesn't actually contain any values. M components. These tuples can be, well, okay, so a standard pair is explicitly 2 length long, right? So you give type 1, type 2. A tuple can be 0 to a lot. So you don't actually have to give it anything. This just exists as a tuple, which is super nice. I'm learning to really love tuples in ECS. I try to do that kind of convention, but after a while I switch back because I don't see any benefits to it. Hey man, I'm in the learning stage. Do I tell you guys about my pet peeve in like college courses and shit? This is like one of my biggest pet peeves. I really don't like it when the students like, I don't want to do that. I don't want to learn that way. I don't want to put C in front of all my structs. And it's like, dude, come on. It's a college course. Just put the fucking C. That's the way I'm doing it. Like, I wouldn't put C here like in practice for every component, right? That's not something I would do normally in my games. But if I'm learning, like, what the fuck do I know? It's the unknown, you know? I don't know what I'm shitty at. Maybe I am terrible at names. Maybe they should have a C there. I don't know. But the college professor, who this guy is, says, yeah, we're going to do this here. You know what? Who am I to question him? He knows his shit. He does this shit for a living. I'm an idiot, all right?
C transform, C gravity, C whatever.
Okay, we did that.
And that's going to typing out a new class, having the same C in front of it is going to be nice for IntelliSense and stuff inside Visual Studio. So it's nice to have a common C in front of all.
I don't know why that would
classes.
be better in VTube Studio. Sorry, VTuber Visual Studio. I never had trouble with IntelliSense finding a variable, but maybe it's because I haven't had like a program with like 2 million lines of code.
It's going to be very, very easy to implement entity component storage option number 1 with this. So option number 1, sorry, I meant, so option number 1.
Oh, that's the shitty version, right? Yeah, okay.
Right? An example and option number 4, we'll get back to those later. Okay? So here's an example class, the transform class. What is a transform? So in mathematics,
wait, this is a system, isn't it? This isn't a component. Class transform. Oh, it is a component. Class component transform public 2D vector position 0, 0, 2D vector velocity 0, 0, C transform constructor. Oh, he wants like a blank constructor and a real one. Transform constructor const 2D vector reference value P, reference value V, position P, velocity V. Oh, why isn't this a system? So you're going to take the position of, you're going to take a position, which is a vector, and you're going to have a velocity, which is a vector. A system only contains logic, not data. Isn't this logic? A component only contains data, no logic. Yeah, this is... Oh, this is data. Oh my god, wait. No, it's data, position, velocity. But what's the point? Why is this an independent object type as a class? Isn't the point of, like, how is this different than a struct? What is this, a position value? How is it different than this? Because that's well, it's a transform, so it has velocity and stuff. But how is it different than, you know, this XY value here and C velocity. How is that any different? I guess because it's one object type? I just didn't think you would want a constructor. Do all of these need constructors then? So this needs like C position, empty bracket, empty braces. That's for it's I'm sure he'll talk about it. I think that needs to be there. And then C position bracket SDLF point P value or value colon point value empty argument. So something like that I have to do every time. Unless you need encapsulation, at this point I see no reason to encapsulate these yet. Really? I didn't think this is the direction we were going to go in. I really thought these would just be structs. Although I guess I could see the argument that if you call the struct or if you give it a value, it's important that you identify what these values are. But then again, if you don't even have this, then you still have the values. I don't know the difference.
Transform essentially just means like where you are or how you are moving within a space, right? So if you transform something, you're moving it within a space. So the first component and the most important component that we're going to have is our transform component. So our transform component is going to have two elements. It's going to have a position and a velocity. The position and the velocity are going to be of type vec2, and I'm going to be talking about vec2 later in this lecture. And I'm going to be doing some live coding about it.
But just keep in mind a vec2, by the way, is just a 2D array where you have an X value array and a Y value array. And it's easier to do matrix math if you have this 2D value. So that way you can do X and Y math independently of each other. Whereas if you have a single array with XY values, it's going to be element 0 and element 1 are X and Y. Element 2 and 3 are X and Y. And it just gets a little bit like verbose and finicky if you have just one line of memory that contains all X, Y, Z values or whatever it is, especially when you get to like 3D and 4D math. So what he's saying is that like, okay, well, in a 2D situation, you want a 2D array of position, velocity, whatever. And it's just a better implementation. I think that's what vec2 means.
Vec2 is essentially just a class that stores an X and a Y. It's almost like a point, but it's a 2D vector, okay? And so it's going to have an X and a Y, and we're going to set those up to be 0, 0 when the component is created. Okay. So we're going to have a constructor.
I still don't know why we're constructing this as a class, because when I see this, I see class, and then I see public, and then I see a constructor. So unless we're adding something to private values that we are not adding yet because we're all drooling idiots students here, I don't know why this isn't just a struct, drop the public line, drop the constructors, and it's the exact same thing. Although I guess maybe the advantage of this is you have to define both a position and a velocity value in order to transform. But then why not make transform a system that takes in a position and a velocity value or changes those things if they exist on the thing and it's affected by like speed or something, is movable, stuff like that. I'm surprised that transform, which is like a verb, is going to be a component. That's the only thing that's throwing me off here. I guess it's like transform information would be a better way to phrase this. It doesn't have any benefits besides it has default values of zeros, which is good in its own right. You don't want just floating like, you know, int x, right? You want int x equals 0 if you're going to have anything.
We're going to have a blank constructor because when we store things in vectors later, we're going to want to have a default constructor in order to transform this data that's passed in.
Yeah, we know this. Okay, good.
Have functions on them, such as move or update or render or whatever. And that does the logic associated with the component, but we are not doing that in this course. And you'll see why later on. Here's another example of a shape. So we may have a class.
Okay, so shape makes a little more sense. Shape, what he's going to do is he's going to have a point, a rectangle, maybe like an XY width height situation. I can't imagine what else shape would be.
C shape. And we're going to have, for example, this shape, maybe a circle shape. So we're going to store a SF circle shape.
Oh, he's not using SDL. So he's using SFML, which has circle shape. It's fine. We'll ignore it.
And then we're going to have a default constructor. And we may have another constructor that does some other things. So for assignment 2, we're going to be drawing a bunch of circle shapes. And in order for an entity to have a circle shape that gets drawn to the screen, all we have to do is add the circle shape component to the entity. And then the rendering system will handle the drawing of it for us. Cool. So just recall,
there's a variety of reasons I don't like that.
As we go forward here, that this is our architecture for an entity.
Okay, we're not doing this.
It's going to be storing dead. We're not
doing that. Yeah, we're doing this. Well, almost this version. We're going to have vectors stored, or the tuple store all the vectors for the unique pointers for the components. Okay.
We are storing them in a vector for now, for this example. Okay. Keep in mind that this will all change. This is just an example. Yep. So if I have a vector of entity classes, call that entities, then somehow I get some data, whether or not I read that from a file or I do some logic. I have a vec2 called P. That's going to be my initial position. Then I'm just going to create an entity. So I can just say entity E. And then I'm going to say E.C_transform. So
E.C_transform. Why is that a method of this entity? Oh, because it contains the component. Because it has the component, it can call that object type, which is now going to be equal to the value of standard make shared. So make shared is just a C++ standard library way of adding a shared pointer. That's all. Just make it a shared pointer, whatever value you're going to give it, which in this case is a C transform PV.
Allows us to pass in we have access to our entities and we create, the way we get access to our components.
Oh, and then he pushbacks the entities onto the entity vector and then do stuff. Okay.
And initially, the do stuff function, and of course, this could be any function, any system. This is going to be passed in a reference.
Yeah, reference value. This is like systems now, right?
So, Python or JavaScript.
Let's see. Void do stuff, calling in the reference value of entities for ranged for loop over every entity in the whole vector, including UI. Transform. So this is, the arrow is a referenced value in a struct. So it'd be E dot component transform, value of that component, position, because it has position and velocity. Then we're going to make that position value plus equal itself E dot component transform velocity. So you're taking the component, which contains position and velocity, and then taking that velocity value and adding it to the position value. This is not how I would do this at all, but I get it. I understand it. It's cool.
Script, you're very used to saying like object dot property.
Oh yeah, arrow, okay. We get it.
Dash.
Okay, we get it.
Instead of dealing with X and Y separately, now we have this vec2 object, which you can add together. And I'm going to be showing that at the end of the course.
Oh, that's operator, right? So what he's talking about is something like operator plus fucking int t or int x, int y, return x plus y. I think that's how you implement that. I forget. I haven't done operators before. Int operator. I have no real experience with operator types, to be totally honest with you. I don't know the syntax here. I do know there is some kind of operator for showing you what you do between two entities. So if this is doing it how I wanted it to, and I know this is incorrect syntactically, you could have entity X, entity Y, X dot position is plus equals, well, this would be plus equals. X, yeah, whatever. X position plus equals Y dot position. Something like that. I'm not saying that's how you do it. You probably put that operator under the position value, but in any case, that's kind of what I'm saying here in terms of like what you can do with operators. It just lets you like add things together in a very non-verbose way, but I have very little experience with it.
Then what I can do is I can say, okay, now in order to draw the shape at the given position of the entity, I have to get the shape. So I say e.c shape, and now this is a pointer. Yep. So I say arrow dot set position, and then I give it the position, which is e.c transform arrow pause. Mm-hmm. Okay. So we take the position and then we set the position of the shape within SFML in order to be drawn.
It's great.
Then I can say window.draw the shape. And that's it.
Systems. Okay, I'm not to systems yet. I don't want to learn systems. I get systems. Notes on vec2. Yeah, it's just a 2D vector, right? So vec2 class. So what does he do here?
What a vector multiply or divide on those, and we'll get into these later. Maybe we want to change the length of a vector. Maybe we want to normalize the vector. Maybe we want to rotate the vector, etc.
Okay, so that's what I think of when I think of like systems, which is like rotation, transform, stuff like that. So here he's making a class called vec2, which is a 2D vector, right? So you're going to give it public values, float x and y, default constructor, float xn, yn. So this is your actual constructor you're going to be using. And then bool operator, equals. Gotcha. So this is how you do the operator syntax. So if you wanted a bool operator equal, then const vec2, referenced value RHS, const. So what this is saying is that if you have two different vec2 classes, you can actually compare them via the double equal signs because it will already grab these values accordingly, right? So what you would do is something like, if you wanted to do the same thing here, it'd be like bool operator on our entities equals, which I think the syntax is now parentheses. Yep. It would be then parentheses, const, entity pointer, entity pointer, correct? No, const. Entity, fuck. Sorry, I have no experience with, referenced value. We'll say MID for now. Which is not what you should be doing, but whatever. Const, entity, referenced value, MID, and then return bool, right? Oh, just const. What the fuck? Is that it? There's no way this is it. Operator is not found. Too many parameters for this operator function. Ooh, what's going on here? Too many values for const vec2, which is this, referenced value RHS. Oh. We'll call it RHS for now, but... Oh, is it just the one? Oh, yeah, okay, I got you. Okay, so that's cool. I forget that both instances of the... Both instances are going to have this operator overload. Function definition operator equals not found. What the fuck? Bool operator. What am I missing? This will help you remember operator syntax. Scroll down to the bottom of the page. There's a table. Oh, thank you. Okay, assignment. Okay, we're not that. We're comparing. So comparison, A equals B. So that's what I thought I had here. So this doesn't work though, because the function definition for operator equals is not found. Why? Click on the category name, you'll see the syntax. What? Oh, based. Okay, bool operator const b const. Oh, we did that. Except they did t data space, which doesn't mean anything, right? Must be a class or subspace name. Interesting. So what am I missing here? Why is this function definition not found? Huh. Outside of the class definition. Oh, there you go. So what I'm wanting is that I can do something like entity A, entity B, and then have if, if A equals B, dot MID maybe? No, you wouldn't even do that. I don't know. I'm thinking that's the implementation. It just allows you to skip a lot of it when it comes to like definitions. I just don't know operators that well. I must be missing something obvious here. Maybe I'll read up on operators on my own time just to kind of understand what exactly is going on here. I know the use case. I understand the value of it. I just have no like practical experience with it. There's no space between the operator and equals. It's operator equals. What? No, still the same issue. But in any case, let's continue.
What we're going to do is we're going to create a vec2 class. It's going to have
Thank you.
Up a vec2 position.
Yeah.
And we have
so now you can just say position plus equal speed. Yeah, it's just a nice thing that reduces a lot of syntax. Makes sense. Well, you'll see it a lot more when we actually understand our component implementation. You'll see a lot of that operator types. Yeah, I think that's what we'll stick with for now. I still like the idea of keeping this tuple empty, having m components, and then when we have the entity made in the entity manager that already takes care of this ID situation, it gives it a unique ID number. Then all we have to do as programmers or as data entry people is just to have some file we're reading from that gives it whatever component it needs. And we have to figure out tags. So that's going to be a lot of research on my end. You're missing a definition, which is the function body for the operator. What you have is just declaration. I don't know. I have so little experience with actual operators that I don't feel comfortable giving advice on it.
Speed is a magnitude. So here we go.
Oh, he's giving like practical examples. Okay. This is not what I wanted to see. I wanted to see component stuff. Okay, yeah. He's showing off 2D vectors. Everybody's done that.
Plus.
Oh, here we go. Okay.
Let's do that. So here we go. Up here, this function, so this is going to be the operator. We talked about operator overloading. This is going to be the plus operator. This is going to take in a const vec2 reference. So we're taking in a const reference to a vec2. Mm-hmm. And this is going to be the right-hand side of the operator. So I could just call this V, but I like calling it RHS because that's the right-hand side of this binary operator. And this is going to...
That's what RHS stands for? Right-hand side? I thought it was like something specific to our implementation of components. It's just right-hand side. Okay. Based. I like it. Okay, cool. That's it? Oh, dear. Oh dear. What was this one?
Of the entities.
Okay, entity managers. Holy shit, finally. Okay. Jesus Christ. Next. Okay, this was what I wanted to see the whole fucking time. Hold on, not that. This is what I wanted to see the whole time. All right, let's go.
To each entity. Now, identification looks like this. So we've got our entity class. We are going to add a unique integer
left-hand side, right-hand side, RHS.
Identifier to each entity.
Yep.
Now, why would I do that? Well, why would you do that?
Why does every entity need a unique ID? And by every entity, I mean, like, if you're shooting fireballs in Path of Exile, they don't use ECS. I know that. If they shot out like 5 fireballs from the player, every individual fireball is going to have its own unique ID. The reason why is, like, what's an example? The reason why is if you do something like, I'm trying to think of like a good, if you have a build that shoots fireballs, but it shoots really, 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 really slow projectiles. So you go out, you cast fireball, 5 fireballs shoot out, and it's like slower than you are. Then you run to the opposite side of it and you cast fireballs again and they hit each other. What happens? Well, what you can do is be like, okay, no, fuck, this is a bad example. What I was thinking of is like, if you have like collision stuff and you're checking against every individual collision, the final check before you actually collide would be like, or one of the checks would be like, hey, does this have the same ID number as what I'm currently colliding with? And if so, don't collide with it. So in other words, a fireball can't collide with its own self. I don't know how or why that would ever happen, but like a unique ID would prevent it. I'm just trying to think of an example that isn't like collision based, because not every game is going to have collision. Card games don't have collision, right? In our sense of like, you know, platforming. Trying to think of a better example. Maybe like maybe as like a player that you, maybe in like Smash Brothers, when you punch something, if you're punching yourself, you have a check of like, oh wait, the ID is matching on both my punch and the model I'm on, i.e. it's myself, don't do anything. So that might be an example of why you would need a unique ID. How the fuck do I have 15 viewers right now? All I'm doing is like reminding myself how ECS works. Hi everyone, we're making a video game. It's gonna be a weird combination of Binding of Isaac, Vampire Survivors, and maybe just a smidgen of Elements the Game. Nobody's ever heard of that. There's no point even typing that out. We have commissioned artwork for the game. It's all custom. Oh my goodness, it's gonna be fucking fun. It's gonna be great. And we're gonna do it with the ECS, which is something I have never done before. I am an object-oriented fucking weeb. No, well, fuck, I'm not a weeb. I don't like anime, but I am a weeb for C++ object-oriented programming. Don't quote me.
In your code is over or something like self.
Oh my god, it's an ID number.
One way that you would be able to tell if
Jesus.
So the way we are going, and the first entity that is created is going to have the ID of 1, and then that's going to go up and up and up. Actually, I can't remember if it's 0 or 1.
Size T. What was size T again? Size underscore T. This is like a C++ thing, right? A size underscore T is, it depends on the architecture of the operating system, right? Or the system or the machine it's on. Because a size T is whatever the maximum amount of bits there are in an integer or something. Or maybe it's like a 64-bit integer. I don't know. It's just a really, really big integer. It's like the maximum size you could have for whatever bit of your monitor. I don't know. OOP fanatic? Yes. Well, it's totally not, because it's my only experience in programming. Listen, chat, we've made a fucking video game, okay? Well, made. It's not finished, but we have a card game. It exists. We have art. It's the type of a size of expression. It's an unsigned type that is able to store any type size and any array index. Oh. Okay. Able to store any type size in any array index. So if I wanted an array to be really, really, really big and not make it a vector for whatever reason, but I wanted an array that's really, really big, you would use type T as the size of the array, right?
I think we're using 0 for another purpose. So the first entity that's created is going to have the ID of 1, the next one is 2, the next one is 3, and then I'll be able to very easily tell if two entities are the same by just checking their ID. Next is each entity is going to have this string, okay, and that is the tag, and by default, it's going to be called default, so it's going to be given this default string. But if I want to create a player, for example, I would give that player entity a tag of player. If I shoot a bullet and that bullet is created, I'm going to give it the tag of bullet, etc. So that's the tag. And then the last...
This seems like a bad implementation, doesn't it? I feel like if you're going to have... So every entity is going to have a const string of one tag, and it could be player, bullet, enemy, platform, whatever. What's the point of that? I understand why you want tags. I understand that, but I don't know why this is implemented this way. Wouldn't you rather have like an array that contains every tag in the game, and then you give those tags to whatever entity it is? Why const? I don't know. It seems like something you'd not want const, because what happens if like the player's mind controlled and you lose control of it and you want to give like control to the AI? Then it would not have the tag of player. Well, it might still have the tag of player. It would be given the tag of like enemy or something. Like I'm thinking like what's the game that goes boop 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 boop, and it's like the spaceship game, and it's like FTL. That's what it is. Chat, you guys can't make fun of me for saying it. That hold on, you guys heard the intro song to FTL, right? The greatest intro song in the history of video gaming. It's better than fucking Bramblestick Symphony? I forget what it's called. Sticker Brush Symphony. Great fucking song. Fucking love that song. It's a YouTube teaching programming. What'd you expect? Oh, no. This isn't YouTube. This is fucking University of Toronto. Excuse me. University of... Hold on. That's the Professor David Churchill. Where the fuck is this at? Whatever. I know it's some Canadian university. No, it's a university course. This is his lecture. This is his like video lectures for the class. Comp 4300, 4300. It's a real class. Oh, I think he doesn't want people to change ID name tag during entity lifetime and only set it once at construction. Yeah, he's saying every entity is going to have. I wouldn't implement it this way.
I'm going to give it.
I feel like tags should be something that's kind of loosey-goosey, you know? Although, well, let's think about the ultimate loosey-goosey game, which is like Path of Exile. In Path of Exile, do entities change components? I know it's not an ECS game. It's like object-oriented to a fault. If you hear any stories about like how they made character models in that game and how much money they spent fixing it, you know it's not ECS. That shit is like hard-coded object-oriented programming. But hypothetically, if a fireball has the tag skill, is a fireball ever going to be an enemy? If it is an enemy, does it lose the tag skill? If you have a set of armor on the ground, it's an entity item. If you have Animate Guardian and that item turns into a guardian creature that helps you with shit, does that change its tag from item to minion? Or does it have item and minion? I actually don't know how you would implement that. I thought tags were something that like, it was like YouTube video tags where you can have many of them. So that way it gets put into every place it should be in terms of like components and vectors and all that for systems to operate on. Because if you have like, because then in like Binding of Isaac, you could have an enemy that is a bullet, right? So maybe you want to be cute and have like a Bullet Bill on the screen as like an enemy, like from Mario, Bullet Bill. And then you have some power that's like clear all bullets from the screen. Does that enemy who's the Bullet Bill with tag bullet and tag enemy also disappear? Well, yeah, that's what would happen. I just don't know if that means it's going to have multiple tags. I thought it would have multiple tags. That's how I'm assuming we're going to continue here. Because I don't know what it would be like to have a tag system where entities only have one tag and it's const and it never changes and you can't add anything to it and subtract anything to it. That seems weird. It's like, it almost comes across like antithetical to what like the ECS architecture actually gives you. Like when I think of ECS, Entity Component System, I think of like extremely modular, like very plug and play for whatever you want. That's what I'm imagining in my head. So maybe I should reevaluate my assumptions for how ECS is actually supposed to work. Maybe I'm giving it too much credit. Maybe it's a lot simpler than what I'm defining it as, and I just need to get with the program. Maybe that could be the case.
The tag of bullet, etc. So that's the tag. And then the last additional piece of information that we're going to need on an entity is whether or not the entity is currently alive.
I'm assuming by alive he means like it exists, like the UI is alive. Do I want that as a base value on all entities? It's what we did for the bullet shooter, the bullet hell shooter. That's exactly how we did it. We gave every bullet object type a Boolean value of is alive or whatever the equivalent was. And when they went off screen and they were going away from the screen, then they would set that value to false. And if the value was false, we had an iteration every frame where, oh, there's a value that's false. Don't render it anymore. Don't worry about it. Just leave it for later, you know? I don't think we deleted them, maybe. It's been a while since I worked on that project. I don't think we deleted them that frame. I think it just turned it off, so don't waste any processing power on it. And then at the end of like, at the loading screen, we would have culled everything. I don't remember if we deleted them on the spot or culled it. Probably deleted them, actually. It's just a 2D game. So it's interesting we're borrowing from object-oriented programming. If I was going to do a component here, this wouldn't be a component, though, is alive, because this is just, should this even be rendered? I guess it can be a component, but is there ever going to be an entity that never has to concern itself with telling the program, hey, don't, like, cull me at any point? Like, the UI would always be alive. Oh! Not, well... I was about to say not true, but that's not true either. I was about to say, okay, well, what happens if you want to, like, you're in a cutscene or something and the UI goes away? I thought it was like not alive for a second, but that's not true. Alive means if this is false, delete the entity, like free up the memory, like kind of alive. So if you wanted to hide the UI, you would just turn off the component that says, I don't know, art, visibility, something like that. And if that's the case, it would always be alive. So I guess I would rather have it be a component then, right? I don't know. I don't know the value. I guess I could listen to them. That might help.
Now, you might say, well, if the object exists, the entity is alive, right? Well, it turns out that this is going to allow us to do something really nice in terms of how we actually destroy entities. Okay, so
Calling.
let's just leave this here for now. There's just so you know, there is a status essentially on an entity which says whether or not it is alive.
So what he's going to talk about, I'm sure, is what he's saying is like, in a video game, to remove something from existence, like if you shoot a fireball in Path of Exile and it goes over and it hits the enemy and then it explodes and goes away. The question is, if you're programming that, do you want to tell the computer to delete that object and free the memory in that exact moment the fireball explodes? Because the answer is usually no. Instead, you set is alive to false and you just leave it. And what's going to happen is, in like the next frame, maybe it's going to iterate through that vector of like projectiles to animate. It's like, oh, wait, this projectile is not alive. Oh, it's going to move over here. So instead of deleting and freeing the memory, it'll take that memory, that object, and move it to another vector, probably called like a graveyard or something. And that graveyard, what'll happen is at the end of the level or at an appropriate time you decide, or a loading screen, or you go through a door or something, when you know the system is going to have time and resources to do something, then you will delete and free that memory in the graveyard, right? That's what it, like maybe during a victory screen or something, you'll free up the memory because you know the system's going to have resources to do it. Whereas if you like launch out 100 fireballs and they all explode, it's going to cause lag because it's freeing up the memory as you're like removing them from the screen. As someone who has looked into the Minecraft Java source code, Minecraft Java uses ECS. Yeah, I believe you are thinking of isn't traditionally what people think of with ECS. Oh, maybe. Java Minecraft uses ECS and OOP at the same time. Sweet. Or you just manage your own memory. You arena using motherfucker. I know what you're talking about. Oh, baby, that's my goal one day. Oh, that's my life goal. I want to be so good at programming. I'm like, you know what? Fuck you. I'm going to block out my own memory. I'm going to have my own memory management. I want to one day. I'm not good enough at programming to do it, but I want to. I know what an arena is. There are hybrid. Overwatch is hybrid. This project is probably going to be like 90% ECS. That's the goal. It can't be 100%. I don't think it can very easily because we're using SDL, and SDL is going to require certain casting and stuff that's going to make things a little bit difficult to component. If you catch my drift, we'll talk about it when we get to like the actual rendering stage. But right now we're in like the how we're going to manage memory stage. Took me a very long time. Also, Push Toy, hello. Long time no see. It took me a very long time to be comfortable managing my own memory. I don't know if comfortable is the word I'm looking for, but more like there's just stuff I don't know. Like, I can tell you, like, listen, if you wanted me to fake it till I make it, I can talk all day about like concurrency and threads and all that stuff. But if you ask me to program that shit in C++, I just walk out of the interview. I'm like, I'm sorry. I'm going to go have some Burger King. That's the best I can do right now. Holy shit. That's out of my fucking realm. But I can talk about it. It's just when you talk about like memory management and like arenas and stuff, I'm just like, dude, I don't even know how you would begin that process. I talked about threads and concurrency like it's the same thing. But like, dude, like I understand like graphics programming because we have experience with OpenGL. So I understand like, you know, how you would reserve memory, how you would, just because you reserve memory, you can't just call that reserved memory a float. You have to define like, what is a float? That kind of deal. Well, I guess if you manage your own memory, it's C++ would already know what a float is. But even if you like reserve that space for the float, you have to tell it's float. That makes sense. I don't know. Why not use vanilla OpenGL? We did. Oh, sorry, not this project. This project, we're doing ECS with C++ and SDL2. We actually did an OpenGL project just to learn it because I wanted to. Where's our OpenGL tutorial? Oh, you guys ready for this? You guys ready for this action? Look at this. Green screen. Gary, what are you so proud of here? Look at this. 1, 2, 3. How's that for a fucking program? Here, let's do it again. What do you guys want? An equilateral? Boom. Boom. Come on. Come on. Are you guys proud of me for that? That is raw dogging, by the way. OpenGL, okay? We fucking chapter 0 that shit, okay? To that point, all right? I'm proud of our implementation there. What, you guys want some right triangle shit? Hold on. Is that a right triangle? Come on. You guys aren't proud of me enough. Be proud of me. Jeez. I'm your favorite streamer. Love me. Love me. Okay. Honestly, if you want to do what you want to do, you'll basically be on your own, except for us, of course. Well, no, I would be on my own. It's okay. It's fine. Chat, when you say except for us, that means you're going to wait for me to like get to a dead end. And then you're going to be like, ha, idiot. It was easy the entire time. I know how you people think. I know what the fuck you people want. No one talk about OpenGL Triangle no more since Vulkan Triangle hit the field. You don't have the emotes to express my pride. Exactly. Holy shit. And look at this, chat. Oh, no, this is bad. This is just unexpected. I was about to say, I thought this was our implementation of unique pointer for C-based fucking Windows and shit, but that's the other project. Oh, look at that GLSL shit. Oh my God. Look at all this crap just to draw a triangle. God damn. We learned all about that. Hold on. Really thin? Boom. I spent $2 asking for the Vulkan triangle? What? You don't get Vulkan. All right. Thank you for the bits. I appreciate it. But we ain't learning Vulkan until after I graduate. Whoop, not that one. Once I graduate college with my computer science degree. Oh, fuck. God damn it. It got rid of that? Hold on. There we go. Once I graduate college with my computer science degree, then yeah, okay, I'm all for it. But until then, you catch my drift, right? Should we call this game Wafshire or Wafshire? I like this name a lot. I just don't know what to actually call it. God damn it. Fucking ignore that. That's a meme. Man, I hate Microsoft PNG Viewer. I really don't like how easy it is to fuck around with it. There we go. Vulkan. Okay, now continue.
Now, I just said the word status because...
Okay, we know. We know.
For we're writing a AAA game and going for absolute max efficiency, this could be an integer or an enum. And if it was an enum, then I would have to do things like edit the enum, and, we wouldn't know what sort of tags were available before the game design was finished and all sorts of stuff. So let's just leave it as...
Really? Wouldn't you, when it came to like enums, wouldn't you do something like enum class tags? I don't know, fucking player, enemy, bullet, UI, whatever it is, right? And then you would have a standard string, string tag is equal to some tags here. Oh, I guess these would be strings. Can I make these strings? I actually don't even know. Can you make enum classes strings? Yeah, no shot, right? So it would be a unique string tag. Oh, no. It would be... Fuck. How would you implement that? Anyway, that's how I would do it if I was going to do like an enum class, something like that. I think I'm like halfway with making my Vulkan environment. I haven't touched it in months. I should get back to it soon. I don't know. I don't even know what the advantages of Vulkan versus like OpenGL, Chat, do I look better shaved? I do, right? I look much better shaved than my dumbass beard yesterday. Hold on. Where's my beard? I have a video. Hold on. Gary. Oh, there I am. Oh my God, what a dumb UI. Oh, Jesus, Gary. Look at this. Look at this dumbass beard. A bit like, wait, hold on. Fuck. Wild. Look at this beard. This is hideous. What the fuck? I look so much better without a beard, don't I? I can't grow a beard. Dude, I don't even know what it is. I look fucking fat in that with the beard because my beard makes it look like I have like one big fucking fat fuck flob there. And I don't. I'm fucking chiseled, baby. I have a jawline for days. I am, in fact, doing this explicitly to avoid the neck fat, by the way. So I hope you appreciate my back pain for you. I could just sit like this all day. Go full Aaron Hansen on it. Better with beard. Shut the fuck up, Sam Shaw. I don't believe you. Nah. I don't believe you. I don't believe you, dog. Next.
String for now. Our component and whether or not the entity is alive. Then we have our components.
So
right?
we're not doing it like this with all the shared pointers as individual values. We're going to have a... Okay. Every component is going to have a vector that it gets added to every time we add a component to a class, to an entity, class entity, I mean. The entity itself will have a vector of all of the, a tuple of all of the components it's going to contain, which is this. So what we're going to do is we're going to have some way of add component function or method or whatever we're going to call it, method. We're going to have some add component thing. And when we add the component, what's going to happen is we're going to take this whatever struct that it is, the component, add that to a vector that's independent of whatever this is, and add it to this tuple. And I think we're going to have 2 pointers to the same object, I think. This is where like efficiency as shit comes in and my lack of experience. I think we're adding 2 pointers to the same object, but we'll see. We'll see. We'll have to see what it actually implement or what the implementation actually looks like.
Our variables, one for each component type. Then we have a constructor for an entity. So the entity constructor.
When I have entities in our game, am I going to want to define the tag in the constructor? Is that something we're going to do? If I make fireball, which I'm not even saying our game's going to have fireball, but it's an example. If I make entity fireball, am I going to want to immediately define it with a tag of projectile or spell or whatever, and to give it its own unique ID? I don't think so. In fact, I kind of want the entity to be... I kind of want an entity to just be defined on its own with like a default constructor of like no definition. And the reason why is because a lot of these entities are going to be constructed in like XML files and stuff, right? It's going to have its own separate file. So I kind of want a default constructor and then have all of the other components it may have added onto it afterward and pushed back wherever it needs to be on whatever vector it's going to. If you want to take advantage of the ray tracing hardware in your GPU, OpenGL won't work. You'll need Vulkan. Okay, call me a fucking moron. Can't you just make your own ray tracing even in a 2D environment? I don't think it has to be like a shader program thing. Like, what is ray tracing besides like vector math? I feel like I could have ray tracing in in SDL if I really wanted to, right? If I wanted to do a lot of the work myself. I don't see why OpenGL can't do ray tracing. Maybe inefficiently, I guess? I don't know.
Is going to take in a tag and an ID, right? So that makes sense. It's going to be given a tag, which is
it's about support and acceleration. Yeah, but it's so much slower. Oh, okay. I got you, fam. I smell what you're cooking.
This is a player. This is a whatever. And by default, whenever we create an entity, alive is going to be set to true, right? So we're going to give it the tag of player or bullet or whatever. It's going to get it. And on what we pass using.
I want to see the entity manager. That's what I want to see.
A little bit of memory for some really, really good functionality.
Okay.
So what does that mean? In this course, we are going to be storing, or at least for assignment 2, our entity objects in a vector. And in fact, we are going to have a
Type def. He used a type def in 2024 and not using? What the fuck? Using standard vector, standard shared pointer, entity vector. Standard shared pointer entity. Oh, so all entity objects. Yeah, okay, I got you. So it's a vector of all entity objects, which he's just going to define in programming as entity vector. Okay.
a standard vector. If you store a vector of raw entity objects, if you ever want to remove things from that vector, then all of the entities have to shift within that vector, and the copying of all that data can be quite expensive. So again, the trade in this course between usability
we get it.
entities in what we're going to do is we're going to use a C++ functionality called typedef. And so what
C++ is type def? Wasn't that C? Wouldn't you rather do like using standard vector, standard unique pointer, entity, entity vector? Is this not the appropriate way to do it? Oh my god, that is the appropriate way to do it. I thought we were avoiding type defs. Inherit from C, but yes, type def is a C++ feature. I thought you avoided type def for the sake of using the word using, but I guess this does have to be this way, huh? Interesting. Using reverts around, using entity vector to stand for this. Expecting a semicolon. Identifier entity vector not as undefined. You sure about that? Oh, equals. Right. Okay. Yeah, I like this more. Sorry. Jesus, it's been so long since we did like type def shit. I like using more. Wait, can I? No, I can't always auto this. That'd be stupid. I was going to say auto entity vector equals using that, but you can't do that. Using alias name equals type name. Keep in mind, C++ has quite a few different keywords, which do very similar things with small semantic differences. I like this more, though. I'd rather use this. It's so weird. Whenever I see type def, I just think, oh my god, preprocessor directives. Oh my god, C-based programming. Oh shit. Even though it's not really a preprocessor. Well, I guess it is a preprocessor directive, isn't it? Huh. Yes, you could make it work using OpenGL, but you'd have to use a lot of hacks, so don't. Oh, ray tracing? Yeah. Interesting. I didn't realize ray tracing required hacks. I feel like ray tracing is like one of those things like any student of computer science is capable of doing. Chat, did I tell you I'm considering my capstone project for a master's degree, if I got one, to be just recreating the entire STL in C++? That would be a fun little capstone project for a master's degree, wouldn't it? Who wouldn't love that? Ray tracing. Is there a way to get NVIDIA ray tracing in my OpenGL project? Unfortunately, no. You need Vulkan or D3D12 to access hardware ray tracing functionality. Oh, I didn't know that. Damn, NVIDIA. Fucking shit. Note the difference of graphics ray tracing versus ray tracing in vector math. Okay. I don't know. I've never done ray tracing before, so there you learn something every day, baby. Does these headphones make my hair look stupid? Does my haircut look like this without headphones, like with headphones on? Because every time I look over, I think my hair is like spiking up in a weird way, but it's just my headphones. If I have does my hair look stupid? Listen, Chad, I'm very self-conscious about the way I look. Yeah, when I have headphones on, I feel like it's like my hair spikes in a weird way. I don't know. Do I look good with headphones? Probably not. I almost typed an insult there. Oh, it's fine. We're open to it. Chat, you guys sound like abused puppies. You guys can make fun of me. It's okay. It's fine. I'm not going to ban you. I'm not going to be like, let me pull up your history of how long you've been subscribed to my channel. Oh, 2-year subscriber, fucking banned. I'm not going to do that shit. It's like my number one thing. I hate when streamers do that. Oh my God. It's like my biggest pet peeve in the fucking world. It's like, oh, streamer's going to go off on an individual viewer who probably can never voice chat on stream. Oh yeah. No, thank you. I'll just leave the stream. It's just like my least favorite thing streamers do. I don't give a shit if you guys shit on me. Fuck, I can shit on me all the time. I'm not looking at your hair. Oh, you're looking at my pearly white t-shirt that I forgot to bleach, so it looks kind of bluish. Graphics ray tracing is heavy parallelized. Wow, poor posture. Hold on. Oh, there we go. That's better posture, right? Jesus, Gary. Get your posture game going. Graphics ray tracing is heavy parallelized. Tick, tick, boom. Oh my goodness. Chat, we're so distracted. Okay, let's continue.
Type def essentially does is it gives vector, it's a say we have 4 different types.
Oh, there we go. We'll also store separate vectors of entity objects by their tag for quick retrieval. So this is where he implements map. Okay, so let me try to summarize this in my head about what exactly we're going to be doing, just so I know before we actually start, because it's going to get complicated really quick. We are data-driven programming, so we'll start from the bottom up here, okay? Every piece of data in the game, in the program, in the application, will have a very small data type associated with it. An integer, a Boolean value, a rectangle value, however we define that, right? Then, when we have an instance of that component made, it will go to an independent component vector that contains all instances of those components being utilized and pointers to the entities that have it, I think. And then we're going to have entities. These entities can have components added to them, and these components will be stored in a tuple. By tuple, by the way, I mean an array that allows for different object types, booleans, integers, and all that stored on one big array. Call it a tuple. So it'll be stored on a tuple. These tuples can be added to via add component methods. When we add a component via this method, it won't just get added to the tuple, it'll also get added to those component vectors. These entities, now that they are made, or when they're made, they're going to get added to a vector in order, so ascending of when they were made. So the first entity gets spot 0, that kind of stuff. And then we're going to have a separate instance of storing those vectors, storing those entities by pointers in a map. And that's what we're learning about now. I think that's how we're setting everything up. I'm trying, by the way, I'm glad we're learning like this, because I don't think I want to know the actual implementation. We can do that ourselves, right? I can learn that way. I just want to know like the architecture before we actually implement anything. Graphics ray tracing is heavy parallelized. You have any other shirt? White shirt is so bland. I do have shirts, but they're... Oh, I have a Path of Exile shirt. I was about to say, I have a lot of work shirts, and I wear white shirts under my work shirts, and this is the undershirt. I just happen to take off my work shirt when I sit down on the computer, so that's what you guys see every day. We can do a better shirt tomorrow. I could change it up. I can use my work shirt. Hell yeah. And by work shirt, I mean, I got some hella fancy polos, yo. I got like floral patterns. I got stripes. I am the polo fucking king, baby. I feel depressed if I was wearing a white shirt. Why? I like white shirts. Well, I like white shirts when I'm at home. I don't think that's what a tuple is for, an array vector of tuples. But yes, a tuple can store X amount of values as defined in the type arguments. A tuple is an array that can have any arbitrary object types inside that are different. That's all that separates a tuple from an array, besides like C++ standard library methods. There's different, but we'll ignore that for a second. Just in terms of like how it accesses memory and all that. That's definitely not what a tuple is. Fucking link, please. Maybe I severely misunderstand what a tuple is, but I thought it was just some contiguous piece of memory where the values stored in those elements in the memory that are next to each other are not like integer, 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 like a regular array would enforce, but it's like integer, float, boolean, integer, SDL, color, all that shit, right? Oh, CPP reference. The least debated definition of any term. Tuple is a fixed size collection, array, of heterogeneous values. It is a generalization of pair. So I'm correct? A pair is you can have any arbitrary different data types together in one object, two of them. A tuple is a pair, but instead of two elements, it's 0 to a lot. I think that is correct, but you can't push another type into tuple at runtime. Really? So it's so it's a const expression. I forget what the term is. It's either const expression or const eval. You are describing something C++ doesn't have? Okay, this doesn't work how I thought it would. I thought you could have a tuple that would just be a container for arbitrary component types, and we would just add to the tuple and take away from the tuple whenever we want to like change components of an entity. But you're saying that's not possible with tuples. You're saying tuples are like const eval, const expression. I always confuse the two. Const eval or const expression, where it must be known at compile time what is in the tuple and not at runtime, which is very different. Standard vector, standard any is probably the closest to what you're thinking about. Okay. That's interesting. I'm glad you guys told me this now, because we could have seriously fucked that up. That could have been bad. Okay, well, I didn't know that. Make tuple creates a tuple object. Tie creates a tuple value, L value references, whatever. Forward as a tuple. Tuple cat creates a tuple by concatenating any number of tuples. Ooh, I want a tuple cat one day. That'd be a fucking great. Oh my god, imagine throwing a tuple cat into a function. Standard swap, operators, helpers, helper classes, size element, uses allocator, basic common reference, common type formatter. Formatting support for tuple. Determines the common type of a tuple and a tuple-like type. Why is there a fly around me? Interesting. Since the shape of a tuple, its size, the type of its element, and the ordering of those types are part of its type signature, they must all be available at compile time and can only depend on other compile time information. This is very hard to read. Hold on, let me just bloop. This means that many conditional operands on tuples, in particular conditional prepend, append, and filter, are only possible if the conditions can be evaluated at compile time. Oh shit. So given a standard tuple int double int, it is possible to filter on types, returning tuple int int, but not to filter on whether or not each element is positive, because that could change unless they're unsigned or something, unless all of the elements were themselves const expression. As a workaround, one can work with tuples of standard optional, but there is still no way to adjust the size based on runtime information. So theoretically, chat, could I not give every entity a tuple of standard optional, but just make the actual container pretty big in size? Like, that could work, right? Maybe have a vector of unions? Ooh. I never used union before. A union is a special class type that can hold only one of its non-static data members at a time. Oh, I see what you're saying. The union is at least as big as necessary to hold its largest data member, but usually not larger. Okay. Interesting. That's something we'll have to look up later. We're running pretty late today. Let's pause here. Let's continue our game another time. By another time, I mean tomorrow. We're going to be back tomorrow. I'm going to have a fancy ass polo. If he's doing ECS, then inheritance is a no-go. Yeah, pretty much. You got it, Nave. I haven't seen you here before, Nave, by the way. But hey, welcome. I don't know if you like VTubing, but hi. Yeah, isn't the point of ECS to avoid inheritance? Yeah, pretty much. But we're learning. All right, chat, come here. Enough looking at my actual face. Here's my actual face, chat. This is my Goo Boy face. Hello, I'm Gary the Goo Boy. I stream every single day at 4:30 p.m. PST, PDT, Pacific Coast time. So right now it's 7:30, at 4:30 start. Whatever, it's around that. Anyway, hi to all the new people. I stream every single day. Tomorrow, we're making an entity manager, and we are going to be creating entities and then automating how the memory management and pointers work for like creating entities. So if you guys are interested in reaping the rewards of our work we spent today looking at research and stuff, then hey, join us tomorrow. I'm going to be back IRL streaming as well because I have a fancy polo rather than a white t-shirt again. So here, give me a lick. Chat, you're tasting tasty today. I'll see you tomorrow. Where's